Hi, this is the video the video accompanying section 1.7 on valence bond theory. Your book has um, a small write-up on valence bond theory, and I'll leave it to you to read that. But I'm going to give you kind of a quicker idea into why valence bond theory is important for us. And the answer to that is that valence bond theory, the main idea of it is that we need to think about electrons mainly as both waves and particles in the physics sense. Because while they are particles, they're more like waves in how we consider them acting in bonds. This is what valence bond theory says. So what they say is that even though they're particles, they are also waves, like this, okay? And waves, when they interact, physics will tell you can interact one of two ways. The first being if they overlap. Oh, that kind of looks like eyebrows. That's funny. If they overlap, okay, like this, they can either constructively interfere, which is a positive, which means instead of two small waves, now in the middle there, you have a large wave, okay? Yeah, maybe that's a little too big. Maybe it's more like that. Okay. And that tells us that the electron, if we're talking about how this relates to bonding, that tells us that the electron density is stronger in the middle of the bond there between the two atoms. However, it can also be destructive. Sorry, my handwriting is not great, and I'm going to do my best to make it better as this goes on. Oh no, I can't rest my hand on the tablet, so that's part of the issue. Destructive, which is a negative, which means that now whenever you have the two waves come together like this, they actually end up, oh sorry, that's already drawn up there. They actually end up being much less than before. Like there's no density in the middle because they destroy each other. So this has a big impact for us because valence bond theory will tell you that, for instance, a bond between, let's say, a carbon's sp3 orbital, okay, because we're going to talk about that in a later section. A carbon sp3 orbital bonds with a hydrogen only if this is constructive. And if it's destructive, so let's draw that again. So that's the constructive, the positive. But if it's destructive, so see, these are two different phases here, the red and the purple. If the hydrogen now is the purple phase, then this is destructive, and there's no bonding event because there's no positive interaction there with the hydrogen. So that's really the main part of what valence bond theory says, is that sigma bonds, which are single bonds started with an s orbital, much like what hydrogen has and what carbon also has, or orbitals with s character, such as with sp3 orbitals, those form due to constructive interaction, is what valence bond theory says. So this has been 1.7.